How to prepare an STL file for 3D printing. Hello everyone. In this video I'm going to discuss all of the basics you need to know about 3D printing. To get started, I want to discuss about a file format. I said STL file, which is a very common term referred to, especially for people looking for 3D printing. In reality, STL is just a file format. If you look, for example, at SelfCAD's export option, you have options, many different options that you can export. You have obviously SelfCAD's own format. You have GLB, which is basically a format that includes geometry, which is basically details of the object, plus textures. And for Facebook, for example, as you can see, that's what they need, this type of file format, which includes a lot of other information like material and textures. Then you have an STL, which is also, you have two variances of it. You have a binary file, which is much smaller, and then you have a regular file format, text format. Then you have many other file formats. In common with all of these file formats that you see over here is that they are geometric formats. Some of them, for example, GLB will have additional information, so would be some of these other formats. For example, Colado will have textures and so on. OBJ can be a combination of MTL file, which has formats, which has textures, while STL is simply just the geometry itself. Now, when it comes to 3D printing, most 3D printers, especially FDM printers, accept just basic geometry. There are some color printers that can take textures and so on, but that's actually not supported in SelfCAD's Slicer, which is 3D print. When it comes to CAD formats, there's actually a standard exchange format. So you have different CAD formats. Actually, each software has their own custom format, and they're not interchangeable, but there's a format called step file, which allows you to exchange between CAD software. They will not transfer over parametric type of data, but it will transfer over the basic technology. And if you go to the import section in SelfCAD, you can actually import step files as well. So what this means basically is that any format that has basically geometry, it could be a CAD format, such as step file, or it could be any of the formats that we support for imports, which could be all of the files you see in export plus many additional formats for import. All of them will be converted into a SelfCAD format, and then you can go 3D print. So you have now two options. You have an option to use the 3D print option, and as I said, this doesn't really matter which format you import it, because it's technically converted into SelfCAD's format, which then sends to 3D print. However, if you do not want to use the 3D print option and you want to print them directly, your own slicer, some printers have their own slicer and prefer people use that. In that case, you would be better off exporting it as an STL format, as this is the standard for 3D printing, and then you would basically upload it into their slicer. Okay, so with that said, let's get started with the idea about SelfCAD's slicer and to show you a lot of things. But before I do that, I actually want to show you one additional thing. And this is that this object actually is not manifold. The sense it's not manifold, first of all, how I can know it. So there's a lot of ways you can test it. For now, I'll check a basic tool, which I use a lot if you watch my other videos, where I check flip normals, and this gives me a message that this is non-manifold. Now, why is this non-manifold? I have already investigated this, and I want to show you. So if I'm going to go, for example, hide away this face, I'm going to do it by giving it a simple opacity for, let's say, 0. And if I look into this object, you can see that you have sections here. I'll turn on my backface coloring so it's easier to see. This is the inside. So basically each object has an inside and an outside. This is the inside. But here you see there's insides sticking in here also on a lot of pieces. So what's happening here actually is that the person, whoever designed this object, and I took this object, I'm sorry, I forgot to mention that. I took this from Tinkerverse, that I found this object. And this object was designed in a way that someone created these sections, like this entire section, and then top section, all of this, and simply merged them together. They haven't used any tool such as Stitch and Scoop to combine them, which will integrate them in a way that it will make the necessary cuts, and it will also remove the inside faces. So this is a cylindrical part, and if you think about the way it goes, that part of this actually goes inside to this cylinder, and then if you see over here, and this actually needs to be removed, the entire inside section, and it also needs to make the cuts to connect them properly, and this was not done this way. So basically you have an object that's not manifold. Now I'll make a separate video hopefully to discuss two things. First of all, how you can actually fix this, Fixing this basically is very simple. You just have to split them off, and you can use SelfCAD's selection tools, advanced selection tools, to select them, simply split them off, and then use stitch and scoop union to combine them back, which will do the job. And I'll also make hopefully a video discussing, showing how to actually design something like this, because actually it's quite a nice design, and I want to show you how you can actually do it much better. This has 68,000, almost 69,000 faces. It's quite complex, and as I said, it's not manifold. And I want to show you how you can actually do something like this in SelfCAD from scratch. The most interesting part will be how to make this spiral design, which would be a nice video. But back to the topic, what I want to show now here is, and actually purposely use this file that is not manifold, because I want to show you that actually SelfCAD Slicer can also handle these things, and you don't have to worry about it. SelfCAD Slicer will be able to manage this type of stuff by itself, and there's a lot of other things in this object which will allow me to show the basic functionality for the slicer. So with that said, let's get started. I simply click 3D print. Now it will by default load the last printer that I had. I have checked over here an ANET A8 Plus printer, and this is what it is. If I need to change a printer, I just click on it, and I can choose any other printer. For now, I'm just going to go back to my previous printer. Simply click the back button, if that actually works. I'm not sure. Yeah, it does work. Okay, simply clicking the back button, I'm back. Okay, so I have the slicer now. There's a few things you can see. What you see over here is, and this is the general, follows the same rules that you see in the SelfCAD editor, which is basically trying to hide all of the complex things, show you only the basics, and then the more experience you get, the more deeper you can start digging in and start learning more. So if you're new to it and you want to have the basics, what you have to understand is that each printer has its own profile, and a profile means a set of predefined settings. So there's a lot of advanced settings in the settings mode, which we'll see later. The profile provided by the printer provider or by other professionals that use these printers have already set the most common use case. Now there's no such thing the perfect use case, because each object is different, and no one who knows 3D printing very well will use the same profile for each of their prints. You have to customize it according to the object. But I can say it's probably the most common thing for the most common object, something like that. And in that case, what you have over here is a printer selection. Then you have open. If you don't want to click a 3D print, you can just click open and simply open a file and browse your computer. And that will allow you to import objects over here without using SelfCAD's editor. And then you have the quality, which is standard setting. And this basically will mean usually the layer heights, how tightly it cuts it. And we'll come back later, I'll show you the idea of layers. And then there's the idea infill, and again I'll discuss this, what infill means. And then you have supports and materials, which material you're using, which is very important. And then you have the advanced settings. Then you have another thing is that if you're clicking on the object, it opens up these settings. So what I want to show you with this seems to be basic, very basic transformations. Now by default it's checking this object, a center object, and if center object is checked, actually you cannot change position because it needs to be centered. But if you uncheck this, you can actually use these transformations. Now SelfCAD over here in the default in the editor, you have the option to change that, the orientation. You see over here these lines. By default the Y is up and Z is the depth going in. Over here actually this is standard for 3D printing, that the Z would be up. So it's not to confuse, this is a little bit different in SelfCAD. And it's actually automatically converting. So even if you see my application, my editor was set Y to be up, it will automatically flip it and make it like this, that the Z to be up, because this is standard 3D printing, so there's nothing you have to worry about it. With that said, I can move it Y, would be basically back and forth instead of Z in the editor in my case, and move it over here. And as I said, you can center it basically, so just center the object. Next thing is about scale, and this is very interesting about scale. So you have the option to scale it, obviously make it bigger or smaller, and it shows based on a percentage base from the original size. Plus here will be, so here is basically a percentage base, the size that was set in the editor. And then over here, you can customize the size. And then similarly, you have rotation, how to rotate that. But I want to show you in a minute the difference between this scale, which is also depending on the printer you're using. So for this, I'm going to change a printer that is smaller, has a smaller height. So I used the ANET that was 300, I think, something like this. It was 300 by 300 by 350. Let's use a smaller one. Let's say this one's only 150 by 150. So it's only 150 squared. Now, if you look at this object, this actually doesn't have enough space, because you are using here, the height of this was almost 200. So, and this is only 150. So what happened here is that it actually moved it down to 76. Now, you cannot go about this. 76 is the, or 75. Now I see it looks like 75, or let's see if I can probably type in 76. So, no, 75 I guess would be the max that allows me to do it. So it was probably a fraction off, and once I moved the slider, it rounded to 75. And then the same thing in size over here. 149, as you see over here, is the max. That's Z, which is the height. 149 is the highest. So this means that SelfCAD will automatically resize the object to fit into your printer related to the profile you have selected. And then based on that, it will basically allow you to customize it, but within this limits. Okay. Another thing that you can do over here is that you can use the place on surface. So you can decide which side to print it. And there's an easy way that if you can simply click here, and let's say if I want to print it upside down, this basically is done. You know, now you can print it upside down. Now I want to actually move it back the same way. So let me click here, and it's moved back to this way. Okay. So now let's start with the actual slicing. And before I go to the slicing here, let me first slice it, and then I'll show you. So once I start slicing over here, the slicing for an object like this takes about a minute probably. I paused my video for just a few seconds, probably less than a minute, and came back to it. So this is basically it. I want to show you another thing here is actually that if you're used to the SelfCAD editor, I can go back, actually have it still open. The basic rotation is the left mouse. You can change the default behaviors from the camera, whether it's a pan camera and zoom and so on. But the default is that you can use the scroll bar from the mouse is you can use to basically zoom it, scale in. So this basically is a scale. And you can use the right mouse, actually is not working. Right mouse is used for selection in SelfCAD. So zoom would be this, and moving would be holding down the scroll bar. Actually holding down the scroll bar is moving, is basically called pan camera. Rotating the scroll bar is zoom, and left click is rotation, and right click is used for selection. If you think about in this over here, it's the left click is still for rotation the same way. You don't have the option here to set the differences, but if you want to move it, pan the camera, you would use actually the right click. So here it's different. There's no selection here. It's just right click. So it has a little different behavior. So it's good to clarify that. Okay, so now that we sliced that, let's take a look what we have. So first of all, the settings that we have is we have disabled support, and we have enabled 12% infill and support was disabled. Now I didn't play with the material because there's no point of showing it. This is just affects the default settings, which is actually a combination of material plus quality makes a combination of something which is hard to show. So I'm just gonna show it over here. So what we do over here is actually it starts by the end. So let's go back to the beginning, and you can start doing this by basically playing. And actually, by the way, the scroll bar is still scaling over here. So the scroll bar is scaling, left click is rotation. Just the only difference is that instead of using holding down the control bar to move, you actually have the right key to move it. So that's only different here, right mouse. Okay, so now I can start clicking play here and start seeing how this actually starts drawing. This will be very slow, so I can increase the speed, and you can start seeing how this actually shows you how it's going to print. It animates it, how it's actually going to print. So let me stop right here for a second and show you. So what's happening here is that it creates a few different sections. So this outside over here is something called adhesion. What this means is that if you want the printer, the object to stick onto the printer, often if you have, especially if you have tiny objects, small pieces, the force from the nozzle that it's going to move will actually influence this, and it actually may move it. It's not sticking enough to the plate, to the build plate, and it may shift and mess up the entire printing. So the idea here is that you add some thin layer first. It's kind of like the word adhesion is used for scar tissue and things like that, which puts it into context. It's kind of adding a very thin layer, something that sticks things together. And this is something that it's meant to be removed later, but it will add something that the object you start printing then is started to sticking onto it. So that's basically the idea. Now, we use the default, so we didn't customize it, but later we'll show you can customize anything. Then we have the shell, which is basically the outside, how thick the outside should be. And if you can see over here, it has a different setting. You see over here, it has like 3 layers. So there's like 3 layers that is basically going around and adding a thickness. Now the thickness of the layer is something, the default would be based on the setting combination of the quality and also the materials, which will set this, how thick each layer is. But the idea here is it adds a layer over here, and then similarly it adds a layer on each section. So this actually is, if you, let's go back for a second, what happened here is we have the layer on the bottom, which is all of these small pipes you see over here. Now this is kind of a visualization that we see in 3D that SelfCAD has done, how to make it look like. The layers obviously does not look exactly like this, as nice as this, and in a sense it looks nicer, it's stitched together better. This is kind of showing layers, but they need to fuse together. It's not like different independent layers, it's fusing together. It's just a visualization how they would look like. But it's important to understand the concept. The concept is that each slice that it's creating is just a 2D profile. So think about it like if I'm going to make a slice, let's say if I take this, this would be, let's say, something like this. I take this, let's say take this, and let me just copy these profiles. So let me just show you the idea. So from a 3D printing perspective, what we have over here, actually let me show it. Yeah, actually this is nice to show. This is okay. So from a 3D printing perspective, what we have here is we have a layer, which is, let's say, the bottom layer, this polygon, and then we have another layer, bottom layer, and then the material thickness fills in the distance between them. So let's say the distance between, let's say here and this is, let's say 20, and the material thickness is, let's say 10. So we will have 10 going below here, 10 above, and then 10 from this going down, and then this will be filled the gap. So this is basically the idea slicer. It creates slices. Each slice is a 2D layer, and then the material fills it. Now the quality of this is basically done based on the thickness of the layer, which has to do with this, and the thickness of the material, and the material setting has to do with other things, which is based on heat, how much should heat up the material, and how fast it should move. There's a lot of other settings that we'll see later that this basically affects things, but that's basically the concept. So what you see over here is the layers is showing it like individual layers, and you see over here you see it actually even different, like a 10 layers going on over here. They're all visualizations, but it's basically, that's the concept. Okay, so now we start moving up. We have a thickness that is something called a shell. So we already discussed, we have adhesion, which is something that is kind of just something to be removed to make it stick to the board, to the plate. Then we have a thickness, which is for the outside, that's called a shell from the outside. And then we have to decide what we do with the inside. And this is where we have the infill. So if I have no infill, this will be empty, simple void. And if we do more like this, it starts going over here. Now here we have a section that closes, so it's going to add, not an infill, it's going to add basically a shell, again for this section. And then it starts building the inside, the outside and inside for this section. And if you start going through over and over, let's go to this section over here, what we have. You can see here it starts building the entire thing. And if we go to, let's say, this section, going close over here, we can start seeing here actually everything is working as expected, even this section. So we saw this section was actually not manifold. It had this section inside, but you see over here actually it's removed. The inside is removed, and it builds everything correctly. And the reason this is working until it closes the entire shape. Now the reason this is working as it is, it looks actually quite nice. This will print very nicely. The reason is because in the settings, advanced settings, there is something that's called mesh fixes. In mesh fixes, there's a section which is basically called, there's a lot of settings over here. Now, I'm not going to be able to explain everything, will take too much time for this video, but you can hover on each of these info icons, it will tell you what it is. So this will tell you that you can ignore the internal geometry arising from overlapping volumes. So basically, in other words, in simple English, what it means is it will do the same thing Stitch and Scoop is doing. It will remove all of the inside sections, it will union them together. And if I remove this, if I uncheck this, and if I'm going to slice it now, let's actually do now remove the infill. I'll go also to the infill, and over here I have only the option, the minimum will be 12%, but if I go over here, I have an option to make it to 0. So I'll go to slice it now without the infill, and let's slice it. Okay, and if you see over here, this basically is done. Now if you look over here, look what's happening. Let's go down. You see actually it creates And this may create a lot of issues, but you see over here, this actually created here a section that you can see it prints this entire inside, which is not an infill because we have no infill. And also you can see from the color, it's a different color. It's just that you can see over here, this entire section here comes inside. This entire section comes inside here, and it's basically showing everything. So this is very important to note that a lot of times, you need to have these type of fixes. So that's basically it. Okay, so now let's go over a little bit more of the settings just briefly to review what's going on. So we have first the quality, and as I said, this layer height, and you see this is quality. So over here it's naming it just high quality, normal, or just kind of level of qualities. But if you dig deeper into it, you can see what makes up these type of stuff in quality. And that has a combination of the layer height, how thick the layer should be, the initial layer height, the line width. You can customize all of this, and again, you can look at each of these info icons. Will explain it to you. And then there's other settings, which is the shell. As I said, the shell is the difference between the top and bottom and wall thickness, and a lot of these things have more advanced settings. If you click at this arrow, if you see another arrow, you can dig deeper into it, and you can see wall line count. So in this case it was 2, which is the outside. You can see 2 layers. We said before over here there's actually 2 layers. You can see we have 2 layers. You can make it more layers, and you can start playing with very fine details, all of this. And then that's basically the idea of the quality, which will make up the quality. And as I said before, this is actually a combination together with material. So it's quite advanced settings, which takes a combination of these two, and this will actually, the combination of material and quality may change based on setting one and the other, because that's basically how the printer defines them. And then you have the infill, which you've already seen. So over here we have the option. Now it shows other, because the option here is just some most basic infill, and there's some science going into it over there based on strength. And I'm not familiar. We're not gonna supposed to say that pretend that I know it, but I can just tell you that I know of it. I know the concept, but I don't know the tight thing to explain it. But basically the idea is, let's say, suppose that 35% gives it strength X, how strong the material is. If you're going to add to 50, you will have a marginal strength improvement, which is not worth it. So the question is, like, how much infill is worth doing it? So obviously the less the better. It makes it less heavy, makes it much less time printing, and obviously much less material, much cheaper. So you don't want to add more material, and but you also want to be strong. So there is science behind that. What is the preferred material use case? And I guess these are the standard formulas that people use. But if you know what you're doing, you can customize it, any of these materials. And you also have density over here. So there's other stuff. I mean, this is density, but you also have some distance and some other stuff, which is a combination of these. You can read all of these settings. And then you have a pattern, which is actually quite frequently used, where you can have a different pattern, like which we had a grid. If you've seen the infill, the way it looked like, it was a grid. You can change between any of these other infills. Then you have over here advanced settings, which is again infill X offsets and stuff. And again, you have to be familiar with this, which is you have skin overlapping. You have all these type of stuff, which is really advanced stuff that you have to do. And yeah, it's too much with the context of this video. And you can see how much more. There's tons and tons of settings for infill, and different skins and different stuff and all this type of stuff. And then you have the speed, which is basically different speeds for each section. And there are some concepts of retracting the travel here. You have the idea of when the nozzle moves, there's the speed of the nozzle, and then there's, once it finishes a section, what it's doing then. If it's moving back to its original point, it's not moving back, and it needs to retract, and all these type of different settings. And again, there are tons of other videos explaining the concept of each particular section, and you can read these as well. It will take me too much time to explain all of them, and I'm also not an expert in 3D printing, but just to show you where the settings are actually located. And then you have cooling, which is also, it's basically controls exactly everything, the printer, and a lot more advanced settings. So you can keep on digging deeper into it. And usually, the best idea is to use a predefined profile. And if you really know what you're doing, what I've seen many professionals do, they use their own profile. You have an option here, create profile. You can create your profile and save it. And then you can have, let's say you have a particular printer, but you have 5 different type of objects. Each one needs different settings. is just too tedious and too complex to set them every time. So you can basically create a few profiles for different type of objects, and then every time you have a similar object, you select from one of your profiles. So, but definitely the more advanced you get into printing, you will need to create profiles. So different use cases, but it's not hundreds, it may be a few selected, so you can just create a few profiles. Okay, so same thing over here is material actually has much less settings. I mean, there's still quite a lot, but yes, there's a material section. And then support over here, this is actually quite interesting, which we're going to show now on this object. This object actually is quite good to show the support. So let's first see the basics, what will happen in the basic with support. So I'm going to turn on support, and this is a simple toggle. You click on it, you turn it on and turn it off. So if I click enable and I turn on support, now let's see what will happen if I'm going to slice this. If I'm going to slice this using the basic default settings. Okay, so I've paused my video again actually while this was slicing. It took now a little longer, probably, you know, a minute and a half or something like that. But you see over here the results. This is actually hard to recognize the object. All of this gray things of material is the same concept as you see, actually the same color as we have this adhesion stuff, which is kind of something that you need to remove, and that's basically showing this concept over here, and it's something that needs to be removed. But the problem here is this is like so much, it would be really difficult to take this apart, and this needs to be removed and kind of things like that. So let's see how we can customize this into the support settings. So if you go to support, the idea here is you have the option, yes, to generate support or not, which we can toggle from here. And then we have where you want to put support. Okay, you can have only touching the boilerplate or everywhere. Meaning is, for example, over here we have support coming from the bottom up, but then we have again support on top of this thing that sticks out over here. So you can customize it where it needs. But what we need over here is actually the angle. Now each printer is different, and depending also on the material you're using, the heat, the speed, the combination of everything is a difference of how much overlapping tolerance it can have. I mean, technically, theoretically, a printer can only print flat. Each layer is flat, one on top of the other. But it has some tolerance that can go overboard and hang over, an overhang that will still not set and still work. And this is where the angle is. So let's see if I'm going to set this to a 90-degree angle. This automatically means that a lot of places which is relatively simple, that we can afford an overhang, a gradual overhang. So I've seen a lot of people do for 3D printing when they don't want to create support, they basically create a bevel. So which is basically less than 90 degree. It will be, let's say, you know, this, you see the minimum is 80 degree. I can click over here to reset it to the minimum. So it's basically, no, this will reset to others, but the max is actually, it will show you red if you do more than that. So the overhang is 80, that's the max you can do. So if you do something like this, this is rounded. Again, I'm not an expert 3D printing, but what I've seen what people do is that this is something that the printer can handle. You don't really need support for this type of stuff. And this is depending how, you know, overlapping will do. The other thing you can do over here is the type of support, okay? Different type of structure, similar to the Infill. And the line count, okay? And the density. So what I want to reduce over here, density, let's make it just 5. Instead of 15, I'll make it just 5. And then you have, you know, again, a lot of advanced settings. But for now, this should do it. So we'll do this and we'll reslice it. Okay, so now we have sliced it like this, and let's see what we got over here. So I got actually a lot less support. I don't have the support over here, this entire section, because this entire roundness is less than 80-degree angle offset. And then you have over here, you know, just the inside over here, and it's much less thick. I can reduce it more. I've tried it before. If I make it, let's say, just one or different styles, I can basically customize where the support is. In this case, it's much more manageable. It adds it a logical section. Actually, you can see in the 4 corners you have a strong support to underline here, which is a big overhang, because this overhang is too far away, so it's quite away from the base, so it definitely needs the support. But over here it needs it only here a little bit, and then it doesn't need it. So it's kind of quite logical that it knows how to handle this type of stuff. Okay, so let's move to the last thing over here. If you go adhesion, is the same thing over here. You have different concepts. You have a skirt, which you've seen before briefly in other settings, which is basically gives you over here, if you read on it, it's a skirt line, has some different concepts, and you have a brim, you have a raft, And again, you can read all of this. It would take just too much time to explain all of this, but it's the same concept as support. The difference between support and adhesion is meant to what needs to be laid down so the object can stick to the build plate. It shouldn't move around, while support is something that supports an underlining, an overhang, so it shouldn't hang under tight, print on tight air, basically print on air. It needs to print on something, so it needs to put in something. So that's basically it. In mesh fixes I've shown before, and you have a lot of these type of stuff over here, and by default I think it will always union, which is the best way to do it, and depending what it is. So one last thing that I want to show you here is I'm actually going to exit this at this point, because I'm going to open it again without the settings, and I'm going to go back to the original object I have over here. And what will happen if I enter, let's say I'll add something very basic, but think about you want to add some vase over here or something. So what I'm going to do here is I'm simply going to add a simple sphere, and I'm going to align it on top of this object. So let's put it on top, and actually let's put it in a little bit, dent it in, so I'll make it, let's say -20, so it goes in a little bit. Okay, so imagine this is a more complex object over here. Now I'm going to select both of them, and I'm going to go to 3D print. I'm going to print it. What you have over here now, you have this pop-up. You have multiple objects, and it asks me what I need to do. They are parts of a single piece. If I select this option, part of a single piece, it will actually use if the union option in the settings, mesh fixes is combined, it will actually remove the inside part like normal union would do, and will print them as a single piece, everything as expected. But this also means that this entire thing will be removed. It's now 150 height, which is both objects together. And in this case, it's only 54% instead of 75% we had before. The scale is 54% because, and you have to understand one thing, that this scales proportionately, meaning is if the height is being shortened, then it's basically shortened on all sides, otherwise it would lose proportion. So this is doing it quite, different. And this is good if you need to combine the objects. Instead of using stitch and scoop, union, and SelfCAD, you can just do it this way, and it will be basically the same idea. The other option here is, if I do again 3D print, if I choose the other option, they are separate pieces, it will put it like this, and it will automatically put this on the floor, because nothing can print on the air. So if they're separate object, puts it like this. But now what will happen is, if I click on this object, if I uncheck center object, I can actually move them away. So I can click on this object, let's say move it like this, let's say move it here, and now I can click on this object, and I can uncheck center and maybe move this the other way around and something like this. So now you can see we actually can print them separately. They actually do overlap a little bit, so it's too short, this board, so I need to scale it a little bit. But that's basically the concept, how you can manage them as individual objects or as a single object. There's also the other options in SelfCAD to split the object. In this type of object, it's not actually realistic, but many other type of objects, you want to cut them. And this is where you have an option, cube selection, which allows you to cut, or some of the cutting tools over here, which is cut with plane. Usually cut with plane cube selections would be the best way to do it. So I want to show you an idea. Let's say cut with plane. So if I'm going to cut this object in two, I can go to, let's say, select which plane I want to cut, left to right, something like this, and I'll go over here, split object, fill cut, so I give it two separate parts. And now what you see over here, off, so we have now, if I move this away, let's say we have now two separate pieces, and now we can put a different orientation. So let's say if I go now to 3D print with this one, I can just go to put this on the plate, so put it like this, and now you can see I sliced it with the same settings as before, and we need support only here, only this overhangs over here on both sides, and other than that basically there's no support. Maybe a little bit here inside support, and that's basically it. So cases like this can solve a lot for cases when the printer is too small. You need to fit in bigger objects, so you need to split them, but it sometimes may need to create some adapters to be able to stitch them together, and that's a part of the modeling application. and sometimes it's just for a way to avoid eliminate support. And with the combination of SelfCAD's editor and slicer, you basically have everything to clean this up. Okay, finally, let's take a look a little bit here. What you have over here is we've already seen the way you can kind of review how this actually slices. There's also the concept over here. You can gray out complete layers, so I guess it's easier to visualize what's happening. It's just a visualization thing. And then you have also show travel. So this basically will show you how it's actually working. And this is a combination when you're going to set the settings, and I think it's better like this. Yes, with grayed out it's not going to work. You see the red lines, which shows you basically 1000. It's hard to see, maybe on something smaller, so you can see how it actually moves. And this may affect if you're going to play with the advanced settings for how the nozzle moves and retracts, things like that. This may be very helpful. You see exactly how they move and how they do based on the settings, and this may help, but this is basically just professionals. And this over here, you have the filament use, which is basically going to show you how much filament is going to be. This is not a part like real as you move it. It's the entire thing. Even if you go till the end, the filament use stays the same, which is basically you can always look based on support and based on any other settings how much filaments will be. And then finally, last thing is how do you export the G-code. So you basically just save its G-code, and it saves it as a separate file, which you could then put on a flash drive, I guess, and put it to the printer, or in any other software that communicates and manages the printer, which all of these options. So that's basically it. I hope you learned something new. I hope this helped you, and I appreciate your feedback. And let me know in the comments if you want me to show anything else, or if you have any other questions. And thanks for watching. Until next time, bye.